Hi everyone, hopefully everyone can hear me okay. The majority of people who've registered are on now, so I think we'll get underway. Firstly, welcome and thank you for attending this webinar. This is our third in a series on performance testing. Today, we're going to be building on the first session, the introduction and overview webinar, and we're going to be looking at performance load modeling, how to build load profiles required by the performance test tools in order to execute a performance test. This is arguably the most critical element to performance testing and engineering projects. It's the load profiles that ensure the performance tests that you run are as representative as possible of the current and future live operational load. Without this, the results you see in perf test just won't be representative of what you see in live. Today we'll be running through the core inputs, processes and techniques that are used to create a representative load profiles. In practice, this means how we identify the transactions that should be in scope, how we use volumetric and usage data in order to understand the quantity and mix of transactions that we should be running. And this is all building up towards the next webinar, which is going to be a practical performance testing webinar using JMeter, applying the theory that we've looked at so far, and this is currently scheduled for the 17th of May. So a little bit about me. I'm Ash Gawthorpe, one of the co-founders of Ten10. My background's in hardware and software engineering, development and architecture, with plenty of experience in technical testing and performance testing. If you do have a question at any point during today's webinar, as before, please do use the chat window on the right hand side of your screen, and we'll try to answer as many of these as we can. So first of all, let's just have a look at the objectives and what we're trying to achieve here with load modeling. So firstly, if we think about a current system which is in live, so you may need to simulate that current live operational load. This is mainly done for performance testing regression reasons. So as the system is updated and new features and functionality are added to that system, you want to confirm if the performance is improved or degraded with each release before it's actually put live. You also may want to simulate future load. So if the demand on the system is growing over time, how much extra load can the system cope with? If you can predict the rate of increase in load, then you can use this information to plan when you'll need to upgrade the system, perhaps add more resources to it, or maybe even replace it. This can also be used to test for a predicted short-term increase in load, maybe due to marketing activity or an advertising campaign. Secondly, you may be looking to replace a current live system. So again, the two ideas apply here. You may want to simulate that live operational load to ensure that the new system performs at least as well as the current system. And also you may want to simulate future load so you understand how much load this new system can cope with. Because chances are if you're replacing the current system, then you'd normally want to ensure this new system can cope with far more future load than the current one. Finally, it could be a brand new system that you're looking at implementing, where you're wanting to simulate predicted load at grow live and also growth over time. Now this is harder simply because you don't have as much data to go on. Chances are you won't have volumetric and sort of analytics coming out of a live system, and also the information that you're provided with by various teams around what that load will look like can also significantly vary from what you see in live. And in practice, you may be looking to performance test for all these reasons and a few more as well. So a couple of important points here. Today's brand new system will be tomorrow's live operational system. And when it's been running for a while, it's essential you update any load profiles that you created using estimated data with the actual data that you obtain from live operation. Also, you shouldn't think of load profiles as something that you create once and then never revisit. You may wish to test with a consistent load profile for benchmarking purposes between each release, but in order to understand and predict how the system will perform in live, remember that load profiles are essentially living assets and they must be updated regularly with live and volumetric information as you receive it from the live app support teams. I just want to cover here what actually is performance load modeling. So it encompasses a number of things. It's the tools and techniques to gather and analyze information related to the current or expected workload on a system. You then take this load information and you transform that into a set of user journeys, transactions, data requirements, messages, batch processes that form the basis of the performance test scripts. We call this the transaction volume model. We'll come on to the definitions of each one of these terms a little bit later on. No one size fits all. There isn't a single approach to this which encompasses all systems across all different industry verticals. But what we're going to show you today is an example for a sample retail web application. Now, this will be directly applicable to many of you who are watching today, and for those of you where it's less relevant to your organization, at least the domain knowledge around using and interacting with a retail web application will be familiar to everybody, and then you'll be able to apply this knowledge to your own specific domain. And this is part of the essential activity of performance testing that is often neglected. I mentioned before it's very important. I'll mention that again now. When we were thinking about this webinar, we sat around and were recalling times when we'd seen performance testing go wrong. We then looked at this in a bit more detail to kind of examine the sort of root cause of this, and we gathered varying different opinions from different technical resources within 1010. And so on this next slide here, what we have is around 30 different reasons for why performance testing goes wrong, essentially. Now, I'm not going to run through all of these. You should be able to read them all on the screen now, I think, and if you were to revisit the webinar later on, you'd be able to look at them in more detail. But now what I'm going to do, I'm going to highlight the number of these issues relating directly to load modeling. As you can see, it's about half of them. So at least 50%. And actually, if I just highlight these next ones that are indirectly related to it, you can see that pretty much covers off most of the rest. If you essentially take the problems that are related to load modeling and the problems that are related to creation of environments and management of those, you're pretty much hitting 90% of the issues that we find in performance testing. How do we start then? What's the process in order to do this? So firstly, we need to understand system usage information and various key business metrics. This can take many different forms, but really we're looking for data along the lines of how many visits, what's the bounce rate, the average number of page views per visit, how many page views in total, how long does a visitor spend on this site, what's the think time, when information is displayed to the user, how long does it take before the user then performs an additional action. So we can pull this from a number of sources, various analytics packages for a web app. There may be application logging around various business transactions and processes, information from back-end messaging systems, third-party service log files. All of these things and more we can use in order to understand how our system is being used in life. So next we need to understand the non-functional requirements of the system, and we're particularly concerned here with the volumes of activity the system should support, and when it's supporting those volumes, the times that it should be taking to respond, essentially. So how fast should a particular transaction be? And remember, we discussed this in the first webinar about setting response times with percentile value targets. So now we can start to process that volumetric information and the requirements we have, and turn that into sort of transaction targets, i.e. it must process 100 orders per minute, it must support 1200 user sessions per hour, there must be 220 logins in a minute, 300 API calls in an hour. Armed with that information, we can now start defining the key business processes that the users can perform and modeling those and starting to map these to volumetrics. Now this part specifically is the most complex bit that we're going to go into some detail next. Finally, at this point, you're able to define your load profile, which details all the user and backend load to be applied to the system. And then this will then allow you to confirm using the model the volumetric information that your load profile will produce. You can then use to check this against the actual volumetrics achieved, so you can confirm that the load that you're applying to your system closely matches the load that was observed in production. There's a number of best practices to consider here, really. So firstly, you want to use a combination of empirical data from live operations and gather information from documentation and other sources as well, including interviews with relevant technical, functional and business resources. In short, you can't have too many data sources when you are pulling load models together. And also, if you're able to take data from different sources and ensure they correlate as well and all tell the same story, then that's a very, very useful thing to do. If the system isn't live yet, then you need to think about gathering data and usage information from perhaps user acceptance testing, or perhaps any beta rollouts that you've had go on already. Really anything that you can use to base those estimates on to make them as realistic as possible with the information you have. Thirdly, the load models that you produce, you want to ensure that you validate those with all relevant business and technical stakeholders, and also crucially have them sign off on them. If the load profiles are wrong, the results in live will not match those seen in perf test. And if you explain that to those senior stakeholders, we often find that they then spend more time and attention providing you with the information that allows you to build them. I think we touched on this before, but ensure the load models are kept up to date with changing live operational loads, behaviors and business growth. They must be kept up to date as the system changes. As the load changes, that must be incorporated and folded back into the load profiles that you use for your performance testing. And finally, you want to define a number of load models. Don't just have one. You can define the best, expected, and kind of worst case scenarios. There may be key points and key activities or key dates where the load changes, and you'll probably want to model those as well to see how the system will cope. And I guess on the flip side of best practice then, really just a few points to make you aware of and things that you may find when you're starting off down this path. So firstly, it's very rare to have comprehensive system usage information. You really just have to do the best job you can with the information you have, filling in the holes where you find them, but crucially making it clear to stakeholders where you have filled the holes in and what the risk is associated with you doing this. Secondly, system load goals or non-functional requirements are often wildly inaccurate. Whenever you are given them, it's very, very important that you challenge and question them to see the level of thought and the level of work that went into defining them, or whether they've just been made up. One way to do this is to push back and explain the risks of them being inaccurate, and how this could mean that the tests that you see in performance tests are simply not representative of what you see in live. Thirdly, as with all testing, it's about balancing risk with effort and with costs. You can't test everything. There's a balance around testing something which is representative enough while keeping it simple enough and not making it over complex, so you are able to run repeated performance tests as easily as you can. Also be wary of the idea of concurrent users versus available population. If you have 10,000 users that can use your system and are registered for it, that doesn't mean you will have 10,000 of them concurrently at a point in time. Also, if you do have, for example, 5,000 users logged into your system or into your application, it's also very important to understand how much activity is actually going on and how much load that all those users are applying. And finally, the analytics, triggers and logging may not be comprehensive, correct, and can be misleading. Again, question the information, the usage stats, the logs that you're given, and where possible, try and, again, tie these together so you're able to see if they correlate. So these are some high-level peak hour statistics that we have for our example retail application. So within that peak hour, we see approximately 1,300,000 page views, approximately 34,000 visits, with an 11% bounce rate, with an average of 35 page views per visit. The average time that a visitor spends on the site is 15 minutes and 56 seconds, and the average user think time is 28 seconds. So user think time is the time from the application returning data. It's the time for the user to examine that data, to consider it, and then to essentially take an action off the back of it. Here we can see the output of our analytics for our peak hour. We can see there's the area of the web application, the sub area, and how these map to specific URLs that are captured by the analytics tools. And most importantly, we can see the number of times that this was accessed within an hour. So for example, in our peak hour, we can see that we have 32,500 logins. Each entry, each row in this table is an activity. It's an action that the user can perform in order to fulfill some function within your application. We generally call each one of these a transaction. So therefore, in order for our performance test to be representative, what we need to do is we need to execute 1.2 million transactions within the hour, and crucially, that activity, that 1.2 million transactions, needs to be spread proportionally across the relative transactions that we can see here in the table, hitting those percentages on the right hand side. So how do we do this? Well, what we can't do is just hit those individual transactions individually. In practice, users access the site and then browse around, perhaps searching for different things, comparing different items and then purchasing them. Other users maybe browse for a little while and then leave. Other users may just log in to see the status of a particular order. The crucial thing is that many of these types of activities have state. Before you can buy an item, for example, you need to have added items to your basket. Before you're able to log in, you need to have pre-created an account and registered. So the analytics here give us a picture of what parts of the application are being exercised within the hour. So our job now is to work out how we can string these different transactions together into practical user behavior. There's a lot going on here. This is a snapshot of a spreadsheet we use to create and manage load models. It looks worse than it is. It will make sense, I promise. So if you stick with me for the next couple of minutes while I talk you through this. Across the top, we have the different transactions. These are the individual atomic activities a user can perform on our application. These transaction types relate directly back to the analytics that we saw on the previous slide. Down the left-hand side, we have the business processes. We also call these user journeys, and we use the two terms interchangeably. Each of them represents a journey through the system that a simulated user can take, executing a particular combination of the defined transactions. In this spreadsheet, every transaction executed by a particular user journey is highlighted in pink to make it easier to read. Crucially, a single iteration through a user journey may execute multiple executions on one or more particular transactions. Your user journeys need to paint a picture. They need to be explainable. It may be that you have access to application logging that defines for each session exactly what transactions were performed by a user, and you can use this as a baseline data set. It's far more likely you won't, and you'll just have the base analytic data similar to what we saw before, and so you're going to have to create these user journeys yourself. You should be able to explain to someone in plain English exactly what a user journey is doing. So in this example, we have 12 individual user journeys down the side and 13 transactions across the top. This is a fairly manageable number. Sometimes it's more, sometimes it's less, but we find that too few and it's not representative enough, too many and the tests become too complex and unmanageable. It's very, very important that the user journeys must encompass all the important activities and functionality your app performs, as the load test will only be executing these user journeys and the associated transactions. Now, that doesn't mean you need a user journey to cover everything your system can do. Really, it's about focusing on the most important ones based on how often they're executed, the business criticality, and the technical complexity of risk. So if we just consider a particular user journey, in this case, order user. So every time order user runs, it executes a landing page transaction once, select category 30 times, select item 4 times, add to shopping basket 4 times, proceed to checkout once, log in or select new account once, and empty shopping bag once. The numbers to the left of the journey name here, they show the total number of times that we execute that user journey in an hour. So in this example, order user is executed 1,552 times, and each time it's executed by an individual synthetic user creating a user session. If we look on the right hand side of order user, we see the total of all the transactions performed when the user journeys run 1,552 times. So this gives us a total of 65,184 individual transactions executed by the order user journey over the course of an hour. So now we need to repeat this process for all of our 12 user journeys. If you look at the top, you'll see we also have 2 rows of figures, allocation and used for each transaction type. The allocation number is derived from the analytics previously shown, representing the number performed in an hour. The used row is the total number of each type of transaction executed by iterating over all of the user journeys in the model for an hour. So what I've shown you here is the finished model. In practice, you'll need to play with the number of different transactions executed by each user journey, as well as the total number of executions of each user journey. When you do this, what you'll see is that used row number will change. So your task is to come up with the correct combination of numbers that make the used and allocation totals for each transaction as close as possible. If you do this, then what you have is a model of user behavior that you can script within the performance test tool. And if the test tool applies the load in accordance with this model, then the analytics that you would see from your performance test will very closely match the analytics that you've been provided with from live. So some of you may have noticed that we sum the total number of user sessions and the average page views for sessions. These also need to tie in with the volumetric stacks that we gathered earlier. Okay, so now we have this model. How do we translate this into a language that the performance test tool can understand? On this slide, we have a sheet defining the TVM, or transaction volume model. It shows how the performance test tool should be configured to execute the different user journeys, the number of users required to run each user journey, and the ramp-up profile to step the starting of the virtual users so they achieve full volume in 30, 45, or 60 minutes. And crucially in that time, hitting the overall transaction targets that we defined in the last slide. So in order to work out how this works, let's have a quick look at order user again. So how long does order user actually take to run? So there's a number of factors making up the overall time. So it comprises how long it takes for each transaction to return, plus the user think time added by the tool for each transaction. So remember, in practice, the user think time will be averaged around a parameter we configure in the tool. In our example, we have an average user think time of 28 seconds from the information we were provided earlier. Order user comprises 40 total transaction executions. So we can see from the table here that it will take on average 1,596 seconds to complete a single iteration, including think time. So that's around 26 minutes. So therefore, as you can see there in this table, we want to complete 971 user sessions or iterations of that order user journey within an hour. So in order to do that, we need to have 431 users concurrently running order user. So as a sanity check, we can just have a quick think about this, and we can say that we need approximately half the number of virtual users to user sessions, because each user runs in just over 2 complete sessions in an hour. So we can now configure the tool with a user think time of 28 seconds, with the actual value randomized between lower and upper limits, and that we want 431 users executing that order user journey. We don't, however, want to start them all at once. What we want to do is ramp them up and ramp up all the other users performing all the other user journeys over a period of time. Now, pretty much all tools allow you to specify a ramp-up profile. So some do them in different ways, but essentially you're telling the tool how long it should wait between starting each virtual user, and that you can see here, in order to ramp up the users executing order user to their full complement of 431 users over 30 minutes, we'd need to start each user 4.1 seconds apart. If you read along a bit further, you can see that if we wait 8.3 seconds between starting each user, we'd hit our full complement of users within an hour. So we're now able to configure the tool for each user journey type with the correct number of virtual users, configuring that ramp up start time as well within the tool. So we're now finally at a point where we can start our load testing tool with the load profile configured within the tool, knowing that it will hit the transaction targets that we specified over the course of an hour, and that will match, or at least come somewhere near to, the production analytic data that we gathered earlier. Well, thank you for hanging in there. I'm afraid this one's been a bit numerical by its nature, but hopefully that has given you some advice and guidance around load modeling. Next time's session will be far more practical. We've had to get the theory out of the way, I'm afraid, before we can really start on the practical stuff properly. But we're now at a point where we can apply the theory that we've covered in this last 3 webinars into a practical performance test using JMeter. That's everything I wanted to cover today. I appreciate there's a lot of detail here, and that the content today is, by its nature, unfortunately, had to be very numerical and quite sort of detail driven. But hopefully this has been useful. Also, just like the other 2 previous times, this webinar will be available for you to stream in your own time. We have covered a lot of ground, so if there's anything we've passed over too quickly, or anything you maybe didn't quite get, or you just want to revisit, you will be able to review this in your own time. It will be available on our website in a couple of days, and we'll make sure we send you notification around when this will be available. As I mentioned before, everything that we've been doing here, the 3 so far, have really been kind of the primer, and the primer giving you the theoretical knowledge that you need in order for you to be able to really start applying this practically in anger. So we will be doing, the next one will be a practical performance testing webinar and demo with JMeter on the 17th of May. We do just need to think through a little bit around exactly how we're going to do this, and depending on how things go over the next month or so, we may actually end up having to split that out into a couple of sort of half-hour webinars, or maybe even one longer one, just to be able to cover the ground required in order to do that. If anybody has a view on which one of those options they prefer, then please do just let us know. So I'm afraid we kind of run out of time, really. If we'll take a look at the questions later, and if those will be replied to individually, everybody that has submitted a question. So it just remains for me to say thank you very much, everyone, for attending and for your time today. I hope you have a good day, and I look forward to presenting to you again on the 17th of May. Thanks very much. Bye.